Okay, today I'm going to go over some stuff that I have on the table here and some problem that I see people have with their wind turbine. Overheating problem, wind turbine burn up, and so forth. So I'm going to show you the best way you should have your wind turbine set up and the stuff that you need to do, okay? Because first of all, before you do anything, you have to know the theory of everything before you can know how stuff work. If you know how it works, it's easy for you to figure out problem and what to do. Because I've been working like this over 5 years now, and this is my, what you call it, this is my inverter. It's 10,000 watt inverter, very powerful. Most companies I see people have is that you don't have the output that the manufacturer specifies you can get from this inverter, and there's a lot of reasons why you don't get that. So I'm going to explain that further down, okay? So I'm going to explain some of the product that I have on this table and how they work, okay? So first I'm going to start with the motor here. It's a half horsepower motor, and what it does, because I don't have wind in here, so I use this as my wind. And this is my wind generator. This does be on top of a pole that's spinning with a blade. Okay, but it's the same process. You spin it, it gives you the AC voltage. Okay, and then the AC voltage is being converted to DC voltage. Okay, with this bridge rectifier here. Okay, so what's coming here hit AC volt, and what's coming out is DC. Alright, and this DC volt will go to your battery bank, 12 volt battery bank, 24, 48, depends what system you have. And then this battery bank give voltage to your inverter, which take 12 volt and step it up to 120, 110 voltage. That's going to use your household appliances here. Okay, so the thing most people does, and which is no good, to set up your wind turbine as a dump load. Okay, I forgot to mention something. This is a heat sink. This take the extra energy that you don't want to convert it here. Alright, and this is a charge controller. You can use it as a dump load or a disconnect, whichever one you prefer, but disconnect is no good because I'm going to explain further to show you why it's no good. Okay, and this is the next charge control. Does the same thing, but these things are not user friendly. You have to like almost be a rocket scientist just to program some of these things. Okay, so we're gonna talk about that later. So now what people I see do most, they don't realize what they're doing. Okay, because you see, when you use your wind turbine as a dump load, basically what you're doing, you put in strain on your generator. Because when it's charging the battery, you will give it more power to charge the battery. So now when your battery is fully charged, you just set it up as a disconnect. It's going to disconnect the wind turbine power from the battery. So eventually what happened to that, the wind turbine is going to speed up because now it doesn't have a load. Then when your battery drops back to 11 volt or 10 volt, whatever you set this here, it's going to give the wind turbine a hard force because now it's need to charge the battery again. So when it's doing that on and off, you're going to have problem with the solar panel or your wind generator. They're not going to last the lifetime it's supposed to last. Okay, right, so now what happened? So we're going to put it on. I'm going to show you what I mean by when you use it at the disconnect. And the best way to use the charge controller here is to use it as a dump load. So when the battery finish charge, when the battery have 12 volt, instead of disconnect from the battery, your wind turbine is going to still keep the same charge because you're going to dump the charge into this heat sink. So this is 12 volts, so what happened, the extra energy that your battery don't need, you will divert it to this heat sink. So what happened, your generator will still have the same torque on it. So nothing changes, because the minute if you disconnect it, the generator is going to speed up. And when you reconnect to charging the battery again, when the battery volt drop, you're going to have the strain going to kick in right away. Okay, so the best way is to use a dump load, so that way you keep steady torque on your generator and the generator is going to be work smoothly. So I'm going to give you a demonstration of what I mean by load and no load. When I say charge and no charge, okay? I'm going to put this on. So I finally get the noise down from the last video I made. The noise is down. So right now we have no load on the generator. Okay. Generator have no load. So you're gonna see that when I put the load, you're gonna see what happened. Okay. That's what happened. So when you use your charge controller to disconnect, what it does, it disconnect, your generator speed up, and connect. So that's what happening when you use it as a, see what happened? So now if I disconnect, and charging again. So that's how your generator is going to be working up. Okay? You don't want that to happen, but it's not good for your generator. Okay, because that's a lot of torque there now. So you see what I mean by disconnecting and reconnecting. Okay? So that's what happens. When you connect, it's the torque, you need a lot of torque because now it's demanding voltage at a random speed. It's random, you need the voltage. Then when you disconnect it now, if your battery bank fully charged, your charge control here disconnect. And that's why it's no good to disconnect. It's best to use it constantly. So I'm going to show you now what happened. If the battery is charging, I connect now. Okay, I put on the wind turbine is running. It's have a load on it, but you don't feel the strain because it's running smoothly because it's not going into disconnect and then connect, because when you do that it's no good. Okay, you can even turn it up and you don't have that. So that's why it's good to use it as a dump load. So you dump the load in the heat sink. Okay, so that's one problem that people have with the wind generator, and that's why it's not gonna last. Okay, the next problem they have, I see, that your wind generator heating up. Because why it's heating up? Okay, now you have to understand that what's the problem why your generator heat up? Because way up in the air you don't know what's going on with it, right? Because the thing that people don't understand with wind generator is its job is to give your battery bank voltage. Your battery bank is to give inverter the amperage, and the inverter is what's going to take the watt out for what you're pulling out from the inverter, right? So what happened now? You have a battery bank and it's not big enough, and your generator and your battery cannot supply what you're taking out here. If you're taking out too much, then you're going to have a problem. So what the inverter is going to be doing, instead of take power from the battery, because the battery don't have enough, it's going to want to start to take power from your generator. And when you start to take power from the generator, that's where the heating starts. It's going to start to heat up, because now it's making this work harder than it usually should work. And the more you pull from this, is the more it's get more torque, because you have the magnet field is going to build up in here, and then you need more torque because now it's supplying the inverter, but that's not the way it's supposed to be on the battery bank. The battery bank is to get its amperage from your battery, not from your generator. Okay, so that's why you have to size what size inverter you're using. Okay, and if you use the inverter, let's say you use a 1,000 watt inverter, your battery at least has to be twice or 3 times the amount of wattage you're going to be pulling. And then you have to know what watt you're going to pull out from here, because you cannot pull more watt than what your battery can give, not the generator, because when you start to pull from your generator, you're going to have a problem overheating your generator. Okay, so that is one problem that people have. People that complain the wind turbine is they don't give, they burn up, they melted, some make with plastic. Well, that's right, you can run a wind turbine with plastic, but the problem is, if you run it like the way I said, you have a good battery bank, it's gonna work fine. But when you start to pull power from your inverter, and your inverter is depleting your battery cannot keep up, then your generator work hard, and that's where you're getting melting from. But plastic is not a good thing to use to cover the wind turbine. I see a lot of people complain about that. So that's one of your plastic melting problem, because your battery bank is not big enough. You're pulling out too much power from here, and what happened? Your generator now is compensating for that, and your generator working more hard. It's not supposed to work. Your generator can run months without no problem, no overheating. I can charge so much battery with this generator and it does not have any overheating. Okay, but the minute I plug something here and I don't have enough amperage in my battery, it's gonna be so hot, the motor works so hard that you can't even fry an egg on these two here, the temperature that we have. Okay, because we are pulling power direct from your generator. You don't need that. You need to pull power from your battery. So if you have a big battery bank, you're gonna enjoy your system better. Okay, and you wouldn't have any problem of maintenance and stuff like that, because these things, they come to last a long time. Okay, so what you're gonna do, I'm gonna do a demonstration now. I'm gonna put a heater here. I'm gonna draw some power from here, and then we're gonna see what's going to happen. All right, so I'm gonna start it again. Now I'm gonna put this light here, and we're gonna see what's gonna happen. Okay, because now I see that I'm not getting a good connection. Okay, so now we're gonna boost it up in voltage, and then voltage drop. So now I'm pulling from the inverter. That's what happened. My amperage is not good. So now, you see the torque is taking this way. I have 11, 12, I need 1, 15, 112. See that I get brighter, because what happened? Like I was saying, my battery is not strong enough. So it's taking power from the generator. Okay? So now I speed it up in the generator. And now I have 112 volts DC. So the faster I go, the faster I get the charge. Okay? But what happened? My generator cannot keep up with the charge, like I said. Because what happened now, I'm taking power from my generator and I can start to feel the temperature.